So what we're looking at now are linear functions problems that involve the concept of parallel and perpendicular lines. Now we know that the direction of a line is determined by its gradient, and so therefore lines which are either parallel or perpendicular to each other may be observed by their gradient. Now parallel lines we know head in exactly the same direction, and therefore their gradients must be the same. Perpendicular lines are also related according to their gradient, but in this way their product, so if two lines are perpendicular, and what we do is we multiply their gradients together and we'll find that that answer will equal -1. Okay, so if we have two gradients, m1 and m2, say, we multiply them together, m1 times m2, the answer will be -1. Which, if we rearrange it, and if you've seen on the notes, we know that it would mean that the gradient of one will equal the negative reciprocal of the other. So what we're going to do now is to have a look at some examples where we find the equations of lines which are either parallel or perpendicular to a certain line and passing through a particular point. Now in this first example, we need to find the equation of the straight line which passes through the point 1, 2 and is parallel to the line with the equation 2x minus y equals 4. Now the first thing we need to do is to look at what the gradient is. So we'll rearrange the equation that's given. And when we do that, we can see that y will equal 2x minus 4, which means our gradient is 2. Now, if it's parallel, which the question is asking for, that means that the gradient of the line that we're interested in, m1, say, is going to be equal to 2, and m2 is also equal to 2. They're both the same. Okay. Now, in order to find the equation of the line, we need to use both the gradient and the point. Into this point gradient formula, y minus y1 equals m outside of x minus x1. And what we can do now is to substitute. We've got y minus 2, y1, equals m, which is 2 outside of x minus x1, which is 1. And expanding, we'll have y minus 2 equals 2x minus 2, and then simplifying by rearranging, we get y equals 2x. So that's our equation. We'll now look at example B. In this one, we have to find the equation of the straight line which passes through that same point, but this time is perpendicular to the line 2x minus y equals 4. So what we have is our m1 is equal to 2, but this time our m2, our second gradient, which is perpendicular, is the negative reciprocal. So it's -1 over m1, which is -1 over 2. And so we substitute into y minus y1. So we'll have y minus 2 equals m, which will be -1/2 outside of x minus x1, which is 1. And we can expand. We'll have y minus 2 equals -1/2 x plus 1/2. And then we can rearrange to be y equals -1/2 x plus 5/2 or 2.5. And that's our equation that we're after. Now in this second example, we're told that we have the vertices A, B, and C with those corresponding coordinates, and that they are vertices of a triangle ABC. What we need to do is, in this question, show that the side AB is perpendicular to the side AC. Okay, so What we need to do then is to look at, well, the side AB is a line. What is the gradient of that line? The side AC is also a line. What's the gradient of that line? If we can show that the gradient of those two lines are the negative reciprocals of each other, or easier still, we multiply the two gradients together and it equals -1, then we've proven that the two sides are perpendicular to each other. So let's write down our important information here. We've got M1 times M2 equals -1. That's what we need to show. We've got our point A and our point B. And our third point C. Each of these are the vertices of our triangle. So we need to show that AB is perpendicular to BC, AC rather. So the next step is to work out the gradient of AB. So using y2 minus y1 over x2 minus x1, we have 3 plus 1 over 2 minus 0, which is 4 over 2, which is 2. Next, our gradient of AC is going to be -2.5 plus 1 divided by 3 minus 0, and that's going to simplify to -1.5 over 3, or -1/2. Now what we need to show is that those two multiply together. So MAB times MAC equals 2 times -1/2. And when we multiply those together, they do in fact equal -1, which is what we needed to show. And therefore we can say that AB is perpendicular to AC.